The next question, that is 24th question, is ready for us. In this question, ABC are three real numbers such that 0 less than C less than B less than A, and the roots alpha beta of the equation cx square plus bx plus a is equal to 0 are imaginary. That is a useful information given to us. Then the first option, mod alpha plus mod beta by 2 is equal to mod alpha into mod beta. The second option, 1 by mod alpha is equal to 1 by mod beta. Third option, that is option C, is 1 by mod alpha plus 1 by mod beta is less than 2. And the last option, that is option D, is 1 by mod alpha plus 1 by mod beta is greater than 2. Let us see what happens. This is the quadratic equation given here. Cx square plus bx plus a is equal to 0. The roots of this equation are imaginary, he is saying. Therefore, the discriminant is b square minus 4ac is less than 0. That is 4ac minus b square is greater than 0. What are the roots here? X is equal to minus b plus or minus root of b square minus 4ac means minus 1 into 4ac minus b square by 2a, that is 2c here. This is therefore equal to minus b plus or minus I root 4ac minus b square by 2c. These are the values of x. Now let me name them alpha and beta, as it is given that alpha and beta are the roots. Alpha is equal to minus b plus I root 4ac minus b square by 2c, and beta is equal to minus b minus I root 4ac minus b square by 2c. Good. Find mod alpha. What is mod alpha? This is equal to, we know that if alpha is equal to some p plus iq, then what is mod alpha? Root of p square plus q square. So it is a root of minus b by 2c whole square, that is b square by 4c square plus this whole square. What is that? What is this? Root of 4ac minus b square whole square is 4ac minus b square by 4c square. Here it is an easy observation that mod alpha is equal to mod beta. Why? Because as and when we are given, or we are to say that the equation, the roots of the equation are imaginary, they are complex conjugates. So if alpha is a complex number, say z, then beta is the complex number z bar. And from the knowledge of complex numbers, we know that mod z is equal to mod z bar. Therefore, mod alpha is equal to mod beta. So the two roots alpha and beta are having the same absolute value. Therefore, mod alpha is equal to mod beta, that is 1 by mod alpha is equal to 1 by mod beta. Hence, among the given options, option B is absolutely correct. Option B is absolutely correct. Well, let us check one more thing. Three more options are also there. Let us examine the validity of those options also. So far, we could have noted that mod alpha is equal to mod beta, and of course 1 by mod alpha is equal to 1 by mod beta. Next one, another important observation here is, we have just noted that mod alpha is equal to mod beta is equal to square root of b square by 4c square plus 4ac minus b square by 4c square. That is nothing but, if you take 4c square as LCM, you will be having plus b square and minus b square go away, leaving you 4ac. That is nothing but root of 1c will be cancelled, 4 will be cancelled, root of a by c. But from data, we are given that 0 less than c less than b less than a. Therefore, A is greater than C. Therefore, A by C is greater than 1. So, root A by C is also greater than 1. Therefore, mod alpha is greater than 1. So, 1 by mod alpha is less than 1. As mod alpha is greater than 1, 1 by mod alpha is less than 1. Similarly, 1 by mod beta is less than 1. You add these two. What is going to happen? 1 by mod alpha plus 1 by mod beta is less than 1 by mod alpha plus 1 by mod beta is less than 2. So, it is also available among the given options, that is in the option C it is available. Hence, we have noticed that both option B and option C are correct and appropriate for this question. So, there are two answers. Here, the main thing which has been utilized here to solve this is alpha and beta are imaginary roots, means they are complex conjugates. If you name one root, say alpha, as some z, automatically the other root beta will be z bar, where z bar is the complex conjugate of z. And from the knowledge of complex numbers, we know that mod z is equal to mod z bar. Hence, mod alpha is equal to mod beta, and if you find in a detailed way, it is observed as greater than 1. Hence, 1 by mod alpha plus 1 by mod beta is less than 2. Both the options, that is option B and option C, are correct for this question. The next question, that is 25th question. There has been given two quadratic equations here. Two expressions are given. The quadratic polynomials defined by real coefficients as p of x is equal to a1x square plus 2b1x plus c1 and q of x is equal to a2x square plus 2b2x plus c2. Of course, both a1 and a2 are non-zero because they are quadratic, and p of x and q of x both take positive values for all x belongs to R. It has been assured that p of x and q of x both take positive values for all x belongs to R. Then the options given, there is another quadratic given, g of x is equal to a1 a2x square plus b1 b2x plus c1 c2. Then g of x takes all positive values only. Second option, that is option B, is g of x takes negative values only. Option C, g of x takes positive and negative values. Option D, nothing can be said about g of x. What is the fate of g of x? Let us examine. The very first quadratic expression given is p of x is equal to a1x square plus 2b1x plus c1 and q of x is equal to a2x square plus 2b2x plus c2. These are the expressions given, 2b1x plus c1. Another important information is involved in the data. We have to use it very carefully. Both p of x and q of x take positive values for all x belongs to R. They take positive values for all x belongs to R. It means that the discriminant of this expression, is negative. That is, d1 is equal to 4b1 square minus 4a1 c1 less than 0. That is, b1 square minus a1 c1 less than 0. That is, b1 square is less than a1 c1. Call this 1. In a similar fashion, same information has been given about q of x also. Hence, its discriminant, that is d2, that is 4b2 square minus 4a2c2 is again less than 0, implies b2 square minus a2c2 is less than 0, implies b2 square is less than a2c2. Call this relation 2. This is, we could have used the data. Let us now think of the requirement. What is the requirement? He is inquiring of the nature of g of x. What is g of x? a1 a2x square plus b1 b2x plus c1 c2 plus c1 c2. Therefore, By looking at the options, we can take a particular decision when you could find the discriminant of g of x. What is the discriminant of g of x? Let me call it some d3. What is the discriminant? b1 b2 whole square minus 4 a1 a2 c1 c2. 4 a1 a2 c1 c2. Yes, b1 square b2 square is, what is b1 square b2 square? It is less than a1 c1, that is less than a2 c2. b1 square is less than a1 c1, b2 square is less than a2 c2. This is a positive number, this is a positive number, that is a positive number. So b1 square b2 square is less than a1 c1 into a2 c2. This is less than a1 c1 a2 c2 minus 4 a1 a2 c1 c2 is again minus 3 a1 a2 c1 c2 less than 0. D3, that is the discriminant of the given expression, is again less than 0. What can you say? We say that g of x also takes positive values only. That is option A is given. Of course, in the question about a1 and a2, it has been given that both a1 and a2 are positive. That is why only a1 a2 is also positive. Therefore, g of x is supposed to take all positive values of x only. Therefore, what is the right option? A. The next question, that is question number 26, is before us. The value of sin x into cos 3x by cos x into sin 3x whenever defined never lies between. That is, he is asking about the range of that particular function, that is sin x into cos 3x by cos x into sin 3x. It never lies between option A 0 and 1, option B minus 1 and 1, option C 1 by 3 and 3, and option D half and 2. Let us see what is the given expression. Y is equal to sin x into cos 3x, sin x into cos 3x by cos x into sin 3x. Now, this can be taken as sin x by cos x by sin 3x by cos 3x. Again, this can be taken as tan x by tan 3x. Now, this can still be simplified as 3 tan x minus tan cube x by 1 minus 3 tan square x. This is y, that is y is equal to t into 1 minus 3t square by 3t minus t cube, where t is equal to tan x. For the sake of brevity, I have taken tan x as some t, so that it could be in a simple form like this. Y is equal to t into 1 minus 3t square by 3t minus t cube. By cancelling t again, it is 1 minus 3t square by 3 minus t square. This is your y. Well, let us cross multiply this. 3y minus yt square is equal to 1 minus 3t square. So, 3y minus 1 is equal to yt square minus 3t square. That is t square into y minus 3. Therefore, t square is equal to 3y minus 1 by y minus 3. T square is equal to 3y minus 1 by y minus 3. This can again be taken as t square is equal to 3y minus 1 into y minus 3 by y minus 3 whole square. I have multiplied both the numerator and denominator by y minus 3. Well, we know something about t square. What is t square? It is non-negative. As it is a perfect square, it is absolutely non-negative. When can it be 0? It can be 0 when tan x is 0. If tan x is 0, then sin x is also 0. Then y is equal to 0. It can then become a constant value. So t square is absolutely greater than 0. Therefore, this is greater than 0. By applying the sign convention, 3y minus 1 into y minus 3 is there. Therefore, 3y minus 1 into y minus 3 is greater than 0. As the denominator is a perfect square, no doubt it is positive. Therefore, to make this true, numerator must also be positive. Therefore, 3y minus 1 into y minus 3 greater than 0. That is, y does not lie between 1 by 3 and 3. 1 by 3 and 3. But you see, 1 by 3, 1 by 2, 2, 3. We have just stated that y does not lie between 1 by 3 and 3. It does mean that it cannot lie between half and 2 also. We need not consider that as a special case again. As we agree with the proposal that y does not lie between 1 by 3 and 3, y surely does not lie between half and 2 also. Therefore, what is the right option? Both the options C and D are correct. The next question, that is the 27th question, is before us. In this question, he is giving us a fourth degree, that is a biquadratic equation has been given. If the roots of the equation x power 4 minus 12x cube plus bx square plus cx plus 81 is equal to 0 are all positive, then the value of b is, he is asking us about b. What is b actually? By looking at the equation, it is sum of all the products of the roots taken two at a time. That is, if alpha, beta, gamma, delta are the roots, then alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta is just nothing but b. We are supposed to find b. Let us try. What are the options given? The first option is minus 54, second option is 54, third option is 27, and the fourth option is minus 27. Let us see. What is the given equation? X power 4 minus 12x cube plus bx square plus cx plus 81 is equal to 0. Okay, let me assume that alpha, beta, gamma, delta be the roots of the given equation. I am naming it some 1. So, what can you say about alpha plus beta plus gamma plus delta? What is alpha plus beta plus gamma plus delta? Sum of the roots is minus b by a, that is minus 12 by 1 is equal to 12. What is sigma alpha beta? That is alpha beta plus alpha gamma plus alpha etc. etc. What is sigma alpha beta? Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus alpha delta. They are 6 in number, of course. This is, come on, this is B. This is, of course, the heroine of the topic, heroine of the problem. That is, this is the thing which we have to learn or to find. The value of B we require. Well, as B and C are unknowns here, the last thing that you can have is alpha, beta, gamma, delta. What is that alpha, beta, gamma, delta? It is 81. It is 81. Well, From the knowledge of progressions, we know that AM is always greater than or equal to GM for any finite set of real numbers. Of course, as GM is going to be considered, they are to be positive, of course. Here, one of the assets in the data is all the roots are positive here. So alpha, beta, gamma, delta are positive. So for those 4 particular positive numbers, we can make use of the result. There is AM greater than or equal to GM. What is AM of alpha, beta, gamma, delta? Alpha plus beta plus gamma plus delta by 4. What is GM? Alpha, beta, gamma, delta whole power 1 by 4. What is alpha plus beta plus gamma plus delta? 12 by 4. Greater than or equal to, what is alpha, beta, gamma, delta? 81. Power 1 by 4. Astonishing. Here, equality holds. 12 by 4 is 3. 81 power 1 by 4 is also 3. Therefore, what could you observe here? AM is equal to GM. AM is equal to GM. As and when arithmetic mean and geometric mean are coinciding, we notice that all the numbers involved in that discussion are equal. What are the numbers involved in the discussion here? Alpha, beta, gamma and delta. Therefore, what can you say? Alpha is equal to beta is equal to gamma is equal to delta. Is equal to 3, of course, as the AM is 3 and GM is 3. AM is 3 and GM is 3. Well, what is the answer? We have done so many things. We did not think of the requirement. What is required here? The value of B. What is the value of B? This is a lengthier sum. Alpha beta plus gamma delta plus gamma alpha delta, etc., etc. If you take alpha is equal to 3, beta is equal to 3, etc., everything here, what do you have? B is equal to sigma alpha beta is equal to 9, that is 3 into 3. 3 into 3, 3 into 3, 3 into 3, 3 into 3. How many times? 6 times. 6 nines are 54. What is the right answer? 54 is the right answer. Is it available in the options? It is available in the second option. That is, option B is the right option for this question. The crucial point we could have made use of in this solution is AM greater than or equal to GM. Why are we able to use that? Because all the roots alpha, beta, gamma and delta are positive, given to be positive. Yes. The next question, that is question number 28. If lambda is the minimum value of the expression mod x minus p plus mod x minus 15 plus mod x minus p minus 15 for x in the range p less than or equal to x less than or equal to 15 and where 0 is less than p is less than 15, then lambda by 5 is. The happiest thing here is we are given the boundaries for both x and p also. P lies between 0 and 15 and x lies between p and 15. Yes. What is the given expression? First of all, let me take f of x is equal to mod x minus p plus mod x minus 15 plus mod x minus p minus 15. But some pieces of information are also given regarding p and x also. What are they? P is less than or equal to x less than or equal to 15 and 0 is less than p is less than 15. Those are the things given. Good. What is mod x minus p? See, p less than or equal to x means x is greater than or equal to p. X is greater than p means mod x minus p is equal to x minus p itself. What is the reason? Since x is greater than or equal to p. we have noticed this. And then mod x minus 15. What can you say about mod x minus 15? X is less than or equal to 15. This is smaller number, this is a big number. So the difference is 15 minus x, since x is less than or equal to 15. And the last one, what is that? Mod x minus p minus 15. What can you say about that? You just add these two, x minus p. X minus p minus 15. Is it positive or negative? P is x minus of p plus 15 or x minus p minus 15. Very easy to consider that this is a negative number. So what is that? So 15 plus p minus x, that is x minus modulus of x minus p minus 15. Making use of that result. Now let me add all these things. LHS will be f of x. RHS will be plus x and minus x will go away, plus p and minus p will go away, and you have 30 minus x. F of x is 30 minus x. Well, when can this f of x be minimum? What is the range of x actually? It lies between p and 15. But p, lies between 0 and 15. When can it be minimum? If x is 15, then it will be minimum. If x is 15, then it will be minimum. Isn't it? If x is 0, 30 maximum. If x is 2, 28 maximum. If x is 15, it will be minimum. Therefore, minimum value of f is equal to 30 minus 15 is equal to 15, and in the question itself lambda is the minimum value of f. Therefore, lambda is equal to 15, and we are not asked to find the value of lambda, but lambda of 5 is required. What is lambda by 5? It is 15 by 5 is equal to 3. Is it available? Yes, of course it is available in the third option, that is option C is the right option. The next question, that is question number 29, is before us. In this question, he has given us a quadratic p of x is equal to x square plus bx plus c, where b and c are integers. If p of x is a factor of both x power 4 plus 6x square plus 25 and 3x power 4 plus 4x square plus 28x plus 5, find the value of p of 1. The most useful information in the data is p of x is a factor of both the biquadratics. Let us first gather the information given. What is p of x? P of x is equal to x square plus bx plus c. This p of x, b and c are integers, is a factor of both the biquadratics x power 4 plus 6x square plus 25, and another biquadratic has been given. What is that? 3x power 4 plus 4x square plus 28x plus 5 plus 5. He has given. Therefore, p of x is a factor of this and factor of this. Therefore, we can write p of x is a factor of 3x power 4 plus 4x square plus 28x plus 5. Is it 5 minus 3 into x to the power of 4 plus 6x square plus 25. You please observe the thing which I could have done here. I would like to cancel this x power 4. Simply with that idea only I have constructed this expression. Thereby you are going to get a quadratic, and you see what is going to happen. Good. P of x is surely a divisor. There is a factor of this, and you can cancel 3x power 4. It is a pre-planned activity. What is the remainder here? 4x square minus 18x square is minus 14x square. That is. And about x's, how many x's are there? Plus 28x. And about constants, this is 5 and this is minus 75. Altogether it is minus 70. So if you get this minus 14 as a common factor, x square minus 2x plus 5. Now you observe, p of x is a quadratic and this is also a quadratic. This is a factor of both of this and this is also a factor of both of this. So you can say p of x is nothing but x square minus 2x plus 5 and thereby getting p of 1 as 1 minus 2 plus 5, 6 minus 2 is 4. So what is the right option? Option D is the right option. Option D is the right option. This is about this question. It is the time for us to go through the next question, that is question number 30. In this question, he is saying, let ABC be the three roots of the equation x cube plus x square minus 333x plus minus 1002 is equal to 0. If p is equal to a cube plus b cube plus c cube, value of p by 2006 is, here a, b, c are the roots of the equation. Not alpha, beta, gamma. He has just changed the name, that's all. A, B, C are the roots of the equation. Let us recall the equation. What is the equation given? The given equation is, this is of course question number 30. Given equation is x cube plus x square minus 333x minus 1002 is equal to 0. Let me name this as equation 1. He has given that A, B, C are the roots of the equation. A, B, C are the roots of 1. He has given roots of 1. So what can you have? Implies sum of the roots A plus B plus C. What can you say? It is minus 1. Sum of the products taken 2 at a time, AB plus BC plus CA. Come on, it is minus 333. Product of the roots ABC, what is that? Minus of minus 1002, that is 1002. Okay, actually we require the value of P, that is A cube plus B cube plus C cube. Let us gather that information. Here A is a root of 1, isn't it? Therefore, what should happen? A cube plus A square minus 333A minus 1002 is equal to 0. From this, A cube is equal to 1002 plus 333A minus A square, correct? Right. Implies sigma A cube is equal to sigma 1002 plus 333 into sigma A minus sigma A square. By sigma A cube, what do we mean? A cube plus B cube plus C cube. That is nothing but P, of course. And what is sigma A? A plus B plus C minus 1. What is sigma A square? We are to find it. If you could find sigma A square, it is enough. You will be able to estimate P, thereby getting the correct and required answer. So we proceed to find sigma A square. Sigma A square is equal to A square plus B square plus C square is equal to A plus B plus C whole square minus 2 into AB plus BC plus CA. What is A plus B plus C? Minus 1. Minus 1 whole square minus 2 into, what is AB plus BC plus CA? Minus of 333. Minus of minus plus 2 into 333 is 666 plus 1 is 667. Now let us make use of this information here to get sigma A cube. What is sigma 1002? 3 into 1002, that is 3006, plus 333 into, what is sigma a? It is a plus b plus c, it is minus 1. What is sigma a square? We have just noted it, it is 666. If you can simplify, you can easily observe that it is just nothing but 2006. It is 2006. What is sigma a cube? A cube plus b cube plus c cube. What is a cube plus b cube plus c cube? Just nothing but p, that is has been given. P is equal to a cube plus b cube plus c cube. Therefore, p is equal to 2006 implies p by 2006. Come on. The right answer is 1. The option available is option A. The one, that is option A, is the right answer. 31st question, that is question number 31. Question number 31. In this question, alpha, beta and gamma are the roots of the equation f of x equal to 0, where f of x is equal to x cube plus x square minus 5x minus 1. Of course, it is a cubic equation. Then the value of integral part of alpha plus integral part of beta plus integral part of gamma and its absolute value, that is modulus of integral part of alpha plus integral part of beta and plus integral part of gamma. That is required. As usual, 4 options are again given. The first option, that is option A, is 1, option B is 2, option C is 3 and option D none. Let us observe the question. To make an attack on the required question, you have to study the nature of the roots alpha, beta and gamma. Where do they lie? And it will be very clear and easy if you are able to trace the graph of f of x. Let us try. What is the given function? F of x is equal to x cube plus x square minus 5x minus 1. What is f dash x? Is 3x square plus 2x minus 5. You observe sum of the coefficients is 0. So, x is equal to 1 is definitely a root of f dash x equal to 0. Therefore, f dash x is equal to 0 implies x is equal to 1 comma minus 5 by 3. By noting these stationary values, x equal to 1 and x is equal to minus 5 by 3, if at all the function f of x attains either maximum or minimum, they can be added to 1 and minus 5 by 3 itself. Well, we could have got an idea. 1 and minus 5 by 3. Let us try to trace the graph of this. Before that, let us first find f of minus 3. F of minus 2, f of minus 5 by 3, f of minus 1, f of 0, f of 1 and f of 2. These answers of course help us to know the nature of the graph. What is f of minus 3? First of all, what is f of minus 3? This is minus 3 whole cube, minus 27, plus 9, plus 15, minus 1, that is minus 4, less than 0. What is f of minus 2? Minus 2 whole cube, minus 2 whole square, minus 5 into minus 2, minus 1, that is minus 8, plus 4, plus 10, minus 1, surely greater than 0. With this simple information, we could have got a particular idea about one root. F of minus 3 is less than 0 and f of minus 2 is greater than 0. There and there itself we can conclude that there is a root between minus 3 and minus 2. Well, find f of minus 5 by 3. If you get substituted this minus 5 by 3 in f of x, then it is very clear to observe that f of minus 5 by 3 is 148 by 27. It is greater than 0. this is greater than 0 and this is also greater than 0. So you need not expect any root of that f of x is equal to 0 between the minus 2 and minus 5 by 3. So, and then f of minus 1. What is f of minus 1? Minus 1 whole cube is minus 1. Minus 1 whole square is 1. 1 and minus 1 go away. Minus 5 into minus 1, 5. 5 minus 1, 4. It is positive. What is f of 0? What is f of 0? What is f of 0? Minus 1. That is negative. Again, observe these two. 4 is greater than 0, minus 1 is less than. Sorry. F of minus 1 is greater than 0 and f of 0 is less than 0. We can expect that another root lies between minus 1 and 0. We could have got the information about two roots. One root is it lies between minus 3 and minus 2. Another root is it lies between minus 1 and 0. Two more things are there before us. Let us find them also. What is f of 1? What is f of 1? 1 plus 1, 2. 1 and minus 1 go away. 1 minus 5 is minus 4. It is also less than 0. What is your inference? You cannot expect a root between 0 and 1. 0 and 1. Just one more hope is there. F of 2. What is f of 2? What f of 2 is? 2 cube is 8. 8 plus 4 is 12. 12 minus 10 is 2. 2 minus 1 is 1 greater than 0. Oh, enough. We should feel happy. Why? Because f of 1 is negative. F of 2 is positive. Therefore, between 1 and 2, we can expect the third root also. We could have got 3 pieces of information regarding the 3 roots present. Let me name them and list out the domain in which they lie. The root lies between minus 3 and minus 2. That is minus 3 less than alpha less than minus 2. Why? Because f of minus 3 is less than 0 and f of minus 2 is greater than 0. These two are of opposite signs. In the properties of continuous functions, if f of x is a continuous function in the interval close and related to b and f of a and f of b are of opposite signs, then a famous mean value theorem says that there is a real number c such that f of c is equal to 0. That is, f of x equal to 0 has a root between a and b. I think so many of you know that it is Bolzano's theorem, Bolzano's mean value theorem. Yes. According to that, between minus 3 and minus 2, we are able to have a root. With the same concept, you apply here also. F of minus 1 is positive and f of 0 is negative. So between minus 1 and 0, there is another root. That is minus 1 less than beta less than 0. Well, we could have arrived at the conclusion regarding the nature of two roots, say alpha and beta. Still, we have to decide the nature of gamma. That is the third root. Observe these two. F of 1 is negative and f of 2 is positive. So between 1 and 2, the third root lies. That is 1 less than gamma less than 2. Well, from this, integral part of alpha is minus 3. From this, integral part of beta is minus 1. From this, integral part of gamma is 1. Add all of them. Integral part of alpha plus integral part of beta plus integral part of gamma is minus 3. But this is not the required one. He has asked us to have the absolute value, that is modulus of this value. Integral part of alpha plus integral part of beta plus integral part of gamma, and absolute value is of course 3. Is it available in the option? Yes, it is. The third option, option C, is the right option for this one. Well, we are able to arrive at the answer only because we could have got the estimation about the position of the roots alpha, beta and gamma by calculating this. By the by, how can we guess these minus 3, minus 2, etc., etc.? We know that minus 5 by 3 lies between minus 2 and minus 1. 1, of course, f of 0 is minus 1. And then if you obtain the graph of this function, it takes the form like this. 0, 1, 2, minus 1, minus 3. One root lies between minus 3 and minus 2. Another root lies between minus 1 and 0. And the other root lies between 1 and 2. Like this the function will be. So to understand this, we could have got almost all real numbers on the graph. This is 1, this is 2. Like this. So this graphical view explains us and helps us very lot to have the nature of this alpha, beta and gamma also. This is about the question.